Welcome to this lecture. In the last few lectures, we have been looking at the life cycle models. We looked at the classical waterfall model, which is the basis for all other models, but then the classical waterfall model is hard to use in a project. The main problem is that it is idealistic and it has no way to accommodate corrections to the work products. It is just a pure waterfall model, but hundreds and thousands of mistakes occur during the development, and the iterative waterfall model overcomes this issue with the classical model and provides feedback paths. We were discussing about the iterative waterfall model in the last lecture. Now, let us get started from that point. The iterative waterfall model, it provides feedback paths, and a mistake in any phase, if it is detected later on, there is a way to correct those mistakes and also redo the subsequent phases. The iterative waterfall model was hugely popular in 1970s and 80s. It was used in almost every development work, but then it had some difficulties for which the newer life cycle models came up. Actually, the difficulties were not felt those days, because the projects were like that for which waterfall model is ideal, but slowly the characteristics of the projects themselves changed. As we were saying that the projects became short and also service projects and so on. First, let us look at what are the strong points of the waterfall model, why it was so popular, and then we will see the deficiencies of the waterfall model, so that the newer life cycle models would be easier to appreciate. The strengths of the waterfall model include e.g. conceptually easy to understand and use. We had seen that it matches with our conceptual understanding of how software is developed. Even if the development staff are inexperienced, they can easily understand the life cycle model and start developing. In the waterfall model, the milestones are well understood by every member of the team. We had seen that the milestones are basically the phase entry and exit. It also provides requirement stability during development. The requirement phase, the requirements are gathered and documented, and after that there is no change to the requirements. So, the developers are not interrupted, they start to develop uninterrupted, they know the exact requirements and they start developing the software. But just imagine what would happen if they start developing and once in a while there is a change and they would have to redo their work, and even the entire plan that they have made, that would have to change, the overall design and so on. So, the waterfall model provides requirement stability. Once the requirement document is prepared, it is not changed. And also for the project manager, this is a very desirable model, because the project manager can plan all the phases, how long each phase will take, when it will complete, and then can staff have the manpower for every phase, and also can track it whether the project is proceeding as per the plan or take corrective action to put it back as per plan. So far looks good, the waterfall model has lot of strengths, but then there are several deficiencies of this model. Let us look at the deficiencies of the waterfall model. Possibly the most problematic deficiency is that the requirements must be known upfront. The customer has to give all the requirements before the project starts, and that is usually not feasible, because the software is not there and the client has to imagine what are all required, and it is very easy to miss requirements, very easy to give ambiguous requirements, wrong requirements, and normally only when the user sees the software says that no, this is not what I wanted something else. In real projects, there is a large number of requirement changes required. The customer in the beginning of the project cannot visualize the exact requirements, and as the project proceeds, the customer can say that, see, this is not what I want, and even the business of the user might change, his methodology and so on, he might want changes on that account also. The second problem with the waterfall model is that it gives a false impression of progress. That is, the project manager may see that the phases are getting complete, the documents are getting ready, and the project manager thinks that the project is progressing fine, but then the problem starts with the integration testing. Once the integration starts, then the problems appear that all the modules they need changes, because the modules were developed thinking that the other functionalities, their parameters and so on, but then in reality it is not like that. There will be problem in integration. This is one of the major problem area here in waterfall model, and the delay, schedule delay starts from the integration, and the project gets delayed further and so on. Another problem is that the customer is kept out of the development. The customer defines the problem and then just waits for the software to be developed, and once he gets the software, then he uses it and says, no, this is not what I wanted. He needs lot of changes to the software. So, one of the problem in the waterfall model is that once the software is complete, it rarely meets the customer requirement, and the reason is that the customer is kept out of the development work. Let us see the projects for which the waterfall model is suitable. If the requirements are well known and stable, if many software has been developed, and this is just one of that, so that it is well understood that what is required of the software and can be frozen upfront. The technology is well understood, how the development will occur, what technologies will be used and so on, and also the development team is familiar with the software to be developed. If you look at these characteristics, these are basically some software which exists, and we just want to have a small change version of that, and the developers have already developed similar software. But then if we want to develop customized software, let us say we had a software and we just want to add few changes to that, then the waterfall model will not be suitable. What about the classical waterfall model? We said that it is not useful for real projects, but does it have any use at all? Okay. One thing is that all documentation of a project is actually done as per the classical waterfall model. The development might have occurred using the iterative model or any other model, but then the documents are written as if the classical waterfall model was used. Let us understand why that is the reason. Just think of the way the mathematician proves theorem. Given a problem that he wants to prove, he would work in many directions. He will backtrack, he will change in between, cross it out, start again and so on. But then when he finally writes his theorem, it appears as if a single chain of thought. All the mistakes that he had done, the different alternatives he has tried, etc., are not shown, because that helps somebody to understand it well. If he had included all the mistakes that he did, all the wrong directions he took, backtracked and so on, it would appear extremely confusing for somebody. And that is the precisely same reason why the documentation in software projects are written as if classical waterfall model is used, because that way the documents can be easily understood by somebody trying to understand the documents. Now, let us look at a derivative of the waterfall model. Name is V model. It is a variant of the waterfall model, and it emphasizes verification and validation. So, that really means is that it will be useful for software that are used for safety applications, where reliability, safety are important. The V model is the one that is preferred. The verification and validation activities are spread throughout the entire life cycle. If you remember, in the iterative waterfall model, it was only during the coding phase that unit testing is done, and in the testing phase the integration and system testing is done. But here, starting with the requirements and design, all phases there are verification and validation activities. And the testing activities are planned in parallel with development. As the different aspects of the project progress, more accurate test case designs are done. A visual representation of the model looks like a V shape, and that is the reason why this model is called as a V model. Look at here that starting with project planning, requirement specification, high level design, and then detailed design, finally coding, and then unit testing, integration testing, system testing, and then maintenance. But in every phase, so this part is the development phase on the left side, and on the right side is the testing and maintenance. And if we look at the development phases, during the requirement specification, the plan for system test is done. So, that is the system test cases are designed during the requirement specification, because after all the final software has to conform to the requirements. As far as the final software is concerned, the SRS document is taken, test cases are designed, and then it is executed and checked whether it meets the requirements. In the V model, it is advocated that during the requirement specification phase itself, the system test cases should be written. There are two advantages to that. One is that testability of the requirements is kept in mind, how exactly it will be tested. During the development, we are clear that how it will be tested. And another issue is that in the iterative waterfall model, what do the testers do during the development phases? Do they join only during testing phase? No, not really, they are part of the team. So, what do they do during the testing, requirement specification, design, coding, etc.? What do the testers do? The V model provides a solution to that, and the testers are actually busy here during the requirements specification. They are busy writing the system test cases. During the high level design, they are busy writing the test cases for integration testing and planning for integration testing. During detailed design, they are busy with developing the unit test cases. So, during every development phase, testing is kept in mind and test cases are already developed. So, it becomes easier for the implementers, that is for coding and so on, is to know that what is expected, and they become conscious of the work they do, that it has to finally satisfy those test cases. If we look at the different steps of the V model, we see that during the requirements analysis and specification, some test activity is done, that is system test case design and system test planning. During high level design, the integration test case design and integration planning is done. During detailed design, the unit test design is done. The strength of the V model is obvious, that it emphasizes verification and validation. Every deliverable is made testable. For example, during requirement specification, testing is made kept in mind, and therefore, the requirements become more testable. And also the model is easy to use, it is after all a derivative of the waterfall model, very similar to waterfall model, excepting that the V and V activities, the verification, validation are spread throughout the life cycle. Now, what about the weaknesses of the V model? First is that it suffers from the same weakness as the iterative waterfall model, that is, the requirements are frozen before the project starts, and there is no scope of changing the requirements later on, it is just a waterfall model. Another issue with the waterfall model and also the V model is that it does not support overlapping of phases. This is a problem even for the waterfall model, even though we did not mention it. The problem is something like this, that let us say there are 10 designers working to design, they have designing different parts of the software. Now, let us say one designer completed early and some designers take much more time. So, the one who completed early, what does he do? Does he just wait for the phase to complete, so that he can start the next phase? If the model is followed as it is, then there is lot of idle time, because it does not support overlapping of phases. iteration is not shown here. In the V model, iterations are not iteration between phases is not shown, does not accommodate requirements change, risk handling is not provided. As must be clear that the V model is used when there is high emphasis on safety, reliability, embedded such as the embedded control applications, and the requirements should be known upfront and the solution and technology should be known, and if these are the characteristics of the project, then V model is a good model. Now, let us look at another variant of the waterfall model, which is called as the prototyping model. The prototyping model, as you can see, it is very similar to the waterfall model. The small difference here is that to start with, there is a prototype construction, and the requirements phase is not there actually, it is there as a prototype construction. It is a small change of the waterfall model. Before the development, design, coding etcetera starts, a prototype needs to be built. But what exactly is a prototype? A prototype is a toy implementation of the system. But then how do we get a toy implementation of a system? Let us imagine that we are trying to implement a function. For a toy implement of the function, we might have a table stored inside the function that just looks up the values from the that is required for the function. For which input value, what will be the output? So, for restricted input values, it will work. We have stored that in a table. It would have limited functional capabilities, does not work for many inputs. Functions are simplified as much as possible, for example, by using tables to store the values that are expected, low reliability, inefficient performance. But then why do we need to develop a prototype? Need to develop a prototype because we can show it to the customer. The customer, to start with, it is very hard for the customer to visualize the entire software, and that is one of the reason why the waterfall model is unsuccessful in many projects. It finally does not match the customer's requirements. But since in the prototyping model, before starting the development, we are creating a prototype of the software, the customer will get a better feeling of how the software finally will appear, and he might suggest changes, and that is incorporated into the prototype, and until the customer says okay, that exactly meets his requirement, the prototype refinement continues. Another reason why a prototype needs to be constructed is that sometimes the developers do not know that whether some technical issues can be met. For example, let us say the transaction rate required by the customer is very high, and the developers do not know whether the database will actually be able to provide that sort of transaction rate, and whether it can be updated on the browser. By constructing a prototype, the developers can actually test out that whether they are able to meet the required transaction rate. So, For developing the prototype, there are two advantages. One is that the customer gets a feel of the system and can modify any requirements. The second is technical. The developers might want to experiment with some aspect of the technicalities, and then they can decide which way to start the construction. There is another reason why prototyping is useful is that the customers learn, the developers learn by doing the work. So, the second, once the prototype is complete, they start the development and they can do a better job, and the user also by looking at the prototype can finalize the requirements. There is improved communication with the customer. In the waterfall model, pure waterfall model, the customer feels isolated. For the entire development, the customer has to just wait, but here could have see the prototype and how the system will look like finally. It also reduces the need for documentation, and also typically a prototyping model, the maintenance costs are low because the quality of the development is good here, because once the prototype is constructed, the developers have experience with the software and they can do the actual development in a much better way, and that is the reason why it will incur less maintenance costs. The customer is illustrated about the software, can make up the mind, can specially examine the user interface issues, the format of the display, interactive dialogues and so on, and the developers themselves can examine technical issues. For example, response time of a hardware controller. So, these two, I would say that these are the major advantages of prototype model, that the customer can get a view of the software and also the developers can examine technical issues. We will stop at this point and we will continue in the next lecture. Thank you.